Welcome to the viewers. We discuss today some of the mathematical statements, their equivalent, especially in the idea of topology. Let phi be a function such that x1 tau 1 to x2 tau 2, then show that the following statements are equivalent. First statement is phi is continuous, and second statement is if H be a closed set in tau 2 in x2, then phi inverse of H is closed in x1. We have to prove the result that two statements are equivalent. Now let's watch what happens. Now we say A imply B. Phi inverse of any open set in x2 actually, and if we say this, this is a space, this is another space for x1 tau 1 and x2 tau 2, there is a transformation or function phi, and this is if said to be equivalent statement and it is continuous. We say then if there exists any open set, say O, we find it here, phi inverse of O, any open set in x2, say O, if we consider phi inverse of open, is open, which is open in, that is open in, and it is open in tau 1 in x1 space. We say, and for B case, let H be a closed set in x2, then by using first condition A, what happens there? If H is closed in x2, then phi inverse of, that is open x2 minus H, that is any open set we are using, that is x2 minus H is also open set, is open in x1 region, that is here x2 minus H is open, there is an phi inverse region. If we say phi inverse 1, phi inverse x2 minus H, and this is H, if we say, then suppose this is a one region, say whatever may be the region is, that is x2 minus H, and here we find phi inverse of x2 minus H, and this region. We say here, and concretely if this is a phi inverse O, so it will be phi inverse of x2 minus H, all this type of region which is open in, and this is open in x1, tau 1 in x1, that is any open set, and this phi inverse of x2 minus 1, that will be also equivalent to x2 minus phi inverse of H, is also open in, that is topology tau 1 in x1, we can find it here, also open set phi inverse of x2 minus phi inverse of h. And since x2 minus of phi inverse of h is open, so phi inverse of h is closed in x1. So we find it here, phi inverse of h. Finally we get the result, which indicates A and B are two equivalent statements. And also, if we say another point of result, and this statement, if we say that phi inverse of h is closed in x1, then we can easily find that x2 minus phi inverse of h is also open in x1. Therefore phi inverse of x2 minus h is also open in x1. Since the phi inverse of, if we say this further conclusion, these two statements are equivalent, obviously A imply B, but if we prove only that B imply A, that is assuming phi inverse of h is closed in x1, that is phi inverse of, here we can say x2 minus phi inverse of h is open in x1, any open set, that is phi inverse of x2 minus of h is also open in x1, which shows phi inverse of any open set is also open in x1. Which is the definition of continuity of phi, that is phi is continuous, that is B also imply A. Here this, which indicates A and B are two equivalent state. If we write that it is closed, that is which indicates A imply B, not we write two equivalent statement. After completing these two, we can say that is A and B are equivalent statements. In this way we prove these results. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.